Okay, good morning everyone. Today I'm excited to take you on a journey through the Capstone project developed during our time in the Bangkit program. Our capstone is about real-time productivity monitor for manufacturing in Evomo. First of all, let me introduce my teams. There are Pak Rohadatul IC, Alicia Widya Siva, Fira Retnawati Aiza, and Dwi Ranti Asih as machine learning cohort. And there are Michael Pidev Natalino and Isa as mobile development cohort. Our primary aim today is to provide a comprehensive overview of our capstone project in Bangkit, such as background, present, existing result, implementation and reasoning, result, documentation, and deployment plan. Now let's move on to the next step that will be explained by Alicia.
The background that underlies our project is in today's manufacturing industries, efficiency and productivity are critical for success and competitiveness. Real time monitoring systems are essential to address these issues promptly. Introducing the real time productivity monitor for manufacturing project, aiming to integrate real time monitoring technology into production processes using a mobile application. Develop a mobile platform to assist manufacturing companies in detecting and counting objects on conveyor. Moving on to our reason. So our team came up with this project after identifying the gap between the current state and the company's desired form of manufacturing process. Next is about the existing results that will be presented by Vira.
Okay, so once we have identified the problem, here we make a comparison between the existing project and the expected goal. Currently, Evomo uses the mobile model. While it achieves 80% overall accuracy, we note its sensitivity to lighting condition and its limitation in identifying responsive objects. Then Evomo Hub is an improved model that is not affected by lightning variation and is in the form of TensorFlow light model. Our goal here a more robust system capable of dynamic and accurate performance regardless of environmental factors. And let's now take a look at our workflow of implementation and reasoning. First, we perform data acquisition, labeling, and pre-processing. We apply grayscale, auto-contrast adjustment, saturation, brightness, and exposure in the pre-processing and augmentation step to overcome the light problem. After that, we build model for object detection using transfer learning YOLO as it has advantage in accuracy and speed in real-time detection. Initially, we managed to build a model with EOVA transfer learning with byte-track algorithm for tracking and counting, and we have 99% accuracy with speed of zero point 0.5 millisecond in pre-process, 12.5 millisecond inference, and zero point 0.0 millisecond for loss. And then when we tried to deploy the ULV8 model, we encountered a large number of problems. And after knowing that exporting ULV8 to 100x is still in the development stage, we discussed with our advisor and got advice to change the model. And we tried transfer learning with ULV5, ULV4 Tiny, and MobileNet V2 SSID. And finally, after some consideration, we decided to use transfer learning with YOLO V5 due to problems in implementing YOLO V for Tiny and lack of accuracy with MobileNet. And next will be presented by Dwi Rapti.
Okay, the next is result. I will briefly explain the result of the model that we have created using the YOLO V5S model with the assessment as shown, namely the model achieved an impressive in precision of 0.99 and recall of 0.997 and a mean average precision of 0.993. Move to the next slide. Okay. And in this next model, is the result of the YOLO VA model that we first made. It can be seen that the result obtained in counting and accuracy are satisfactory, but we have faced problem in the deployment section, so that the model we use in the end is YOLO V5S. Okay, move to the next slide. Uh, we will explain the flow of machine learning documentation. In the step 1, there are data acquisition, labeling, and processing. And the step 2, there are step model for transfer learning. And the step 3, download dataset. And step 4, this is training. And the step 5, validation. And the step 6, convert to TF-Lite. The next will be
Okay,
presented by Fidef.
okay. In MD documentation, first of all, we create the UI UX view. We focus on making the UI UX clear and capable of displaying data correctly. Besides that, we use button navigation for assessing its menu. With button navigation, the function on application can be used easily. Secondly, we fail in the application process because the amount of storage from the apply become a 7 gigabyte while the Java buffer can only accept 28 megabyte. Finally, we try to deploy using YOLO v5 and once that work well as a YOLO v5s and YOLO v5n. After some coordination, our team used a YOLO V5S as a main model because more accurate but still not laggy in mobile apps. Moving on UI UX result. This is the end result of the UI UX view we create. The first image is illustrated how many successful, failed, and total number of battle were detected. The second image is the load process when you want to use the camera detection. The third image is a camera that can detect battle and add them to the counter menu. After this, we will explain to deployment plan by Isa.
Okay, for deployment plan, first we are using Kotlin. Initially, we built the application using Kotlin language following the teaching from Bangkit itself. However, we discovered that in Evomo company, they are mostly using Flutter for their mobile development. Therefore, we decided to using Flutter beside native Kotlin language for creating some part in application like plugin API and else. Then, using Flutter, we managed to make a best display for product counter, displaying pie chart, and overall data review of quantity data. After that, we also managed connecting device camera with the application itself using information handler and else. Then, multiple platform. Using Flutter has a benefit for company itself, such as we can use the application on Android, on iOS, on web-based or Windows-based application. So the company has a multiple choice when deploying the application for their need. Next. Okay, so imagine real-time efficiency on your production line using a formal product counting application. With optimal product counting application that using YOLO 5S for count product, boosting accuracy, and also user friendliness, over 80% accuracy for detecting product, a formal product counter application, spot flow, and spot bottleneck, and deflected product, and user worker to manage the production line. And back to IC.
Now, in closing, our time in the Bangkit program has been a transformative experience. Thank you for joining us on this presentation. We also want to thank you to FOMO team for the opportunity and all of the guidance.